Stop shifting arrays wrong. Deleting elements sounds easy. Until interviews destroy you. Let's solve LeetCode 27 with the two-pointer technique. Can you remove elements from an array without creating a new array? Remove every occurrence of a target value. Modify the array in place. Return how many valid elements remain. Classic array problem. But secretly, a two-pointer masterpiece. Brute force says, whenever we find the target value, shift every element after it one step left. Repeat until all targets disappear. Shift again. All targets removed. But look at all that shifting. What if we keep every element we want, instead of deleting elements we don't? Let's see this in action with two pointers. Input array, 0, 1, 2, 2, 3, 0, 4, to remove value, 2. Read 0. Not target. Keep it. Read 1. Not target. Keep it. Read 2. It's the target. Skip it. Read 2. It's the target. Skip it. Read 3. Not target. Keep it. Read 0. Not target. Keep it. Read 4. Not target. Keep it. Read 2. It's the target. Skip it. Scan complete. The first 5 elements are valid. Result, 0, 1, 3, 0, 4 efficient and clean. Here is the optimal solution in Python. We initialize k at 0. Then iterate with I. If the element is not the target, we copy it to index k and increment k. Simple and efficient. And here is the same logic in Java. The logic remains identical across languages. 2 pointers. 1 pass. O of n time. Let's try run the optimal solution. Index 0. Value is 3. Target. Skip it. K stays 0. Index 1. Value is 2. Not target. Copy to k equals 0. Increment k to 1. Index 2. Value is 2. Not target. Copy to k equals 1. Increment k to 2. Index 3. Value is 3. Target. Skip it. K stays 2. Loop ends. Return k equals 2. Only non-target values survive. Bonus advanced method. If the order of elements doesn't matter, we can do even better. Consider the array, 3, 2, 2, 3. We want to remove 3. Index 0 is 3. It's the target. Instead of shifting, swap it with the last element. Now, shrink the effective size n. Check index 0 again. It's now 3, from the end. Still a target. Swap with the new last element at index 2. Shrink n again. Index 0 is now 2. Not the target. Increment I. Index 1 is 2. Not the target. Increment I. Loop ends. Result, 2, to length 2. This avoids shifting entirely. Much faster for many removals. Let's compare all 3 approaches side by side. Brute force. Time complexity O of n squared. Space O of 1. 2 pointers. Time complexity O of n space O of 1. Swap with end. Also time O of n space O of 1. The optimal solutions are significantly faster for large inputs. Choose 2 pointers if order matters. Swap if it doesn't. This isn't just one problem. It's an entire pattern. Remove duplicates. Move zeros. Remove element. They all use the 2-pointer technique. If this made 2 pointers click for you, like and subscribe for more LeetCode patterns. Next up, remove duplicates from sorted array.